At 1746 Coordinated Universal Time on March 14, 2013, researchers at CERN officially confirmed the existence of a particle predicted nearly 50 years prior. But its discovery didn't close a book. It ripped open a cosmic scroll, revealing a riddle that has haunted physics for decades. The riddle is one of profound, almost violent inequality. We are taught that the laws of physics are universal, elegant, symmetrical. Yet, when we inventory the fundamental building blocks of our reality, we find not a democracy, but a rigid, seemingly arbitrary aristocracy. We find a forbidden hierarchy. Consider the top quark. It has a mass of approximately 173 giga-electron volts. To put that in perspective, it weighs about as much as an entire atom of gold. Now consider the electron neutrino. Its mass is so vanishingly small we can only place an upper limit on it, less than 1 electron volt. The gap between them isn't a gentle slope, it's a cliff face. A factor of over 100 trillion. This is like comparing the mass of a single bacterium to the entire Great Pyramid of Giza. And these are just two of the players. This is the seemingly arbitrary masses of fundamental particles. The standard model of particle physics, our most successful and rigorously tested theory of the subatomic world, lists these masses with breathtaking precision. It catalogs the 12 fundamental matter particles, 6 quarks and 6 leptons, and the force-carrying bosons. It can predict the outcomes of particle collisions to an astonishing number of decimal places. But there is one thing it cannot do. It cannot explain. Why this specific hierarchy? Why is the top quark a cosmic heavyweight, while the up and down quarks that form the protons and neutrons inside you are relative lightweights? Why does the photon, the carrier of light itself, have no mass at all, allowing it to traverse the cosmos at the ultimate speed limit? The standard model simply accepts these values as inputs, as fundamental constants of nature that we must measure and plug into the equations. It gives us a list of ingredients, but no cosmic recipe. It's as if we found a perfectly functioning Swiss watch, could describe every gear and spring in meticulous detail, but had absolutely no idea why the designer chose those specific materials and dimensions. This isn't just a matter of academic curiosity. This hierarchy of mass is the very reason our universe is not a featureless sterile void. Mass is not just stuff. In physics, it is inertia. It is a particle's resistance to being accelerated. A massless particle, like a photon, is condemned to travel forever at the speed of light. It cannot be contained, it cannot slow down, it cannot form stable bound structures. It is a perpetual wanderer. Particles with mass, however, can be corralled. They can be slowed, captured in orbits, and assembled into complex systems. The electron's tiny mass is crucial. It's light enough to form vast probabilistic clouds around an atomic nucleus, defining the rules of chemistry and molecular bonds. The precise masses of the up and down quarks are what allow protons and neutrons to be stable, forming the nuclei that are the heart of every atom. If you were to tweak these values, make the down quark slightly heavier than the proton, for instance, the proton would decay, and the entire universe of matter as we know it would dissolve into a fog of radiation and lone neutrons. Existence itself is balanced on this knife edge of seemingly random numbers. So we are left with a profound tension. Our deepest aesthetic sense for physics craves symmetry and explanation, a universe governed by elegant principles. Yet the data whispers of a different reality, one built on a foundation of brute fact numbers that appear to be fine-tuned for complexity, for structure, for us. This chasm between what our theories demand and what our universe displays is known as the hierarchy problem. It's not just about the spread of masses among the known particles. It extends to a deeper, more troubling question. Why is the force of gravity so incomprehensibly weaker than the other fundamental forces? Why is the scale of electrophysics so disconnected from the Planck scale, where gravity is expected to become a quantum force? It all points to the same unsettling conclusion. The universe seems to operate on a need-to-know basis, presenting us with a set of rules that work, but hiding the logic that underpins them. The cosmos is not a level playing field. It is a meticulously structured system, a cosmic caste system where particles are born into their roles, their influence and destiny predetermined by a single fundamental property. What is the source of this cosmic law? Is it merely a frozen accident, a random roll of the dice in the first picosecond of the Big Bang? Or is it the first clue to a deeper, more fundamental principle of reality, a forbidden law that forges the very potential for existence? That burning question, accident or law, forces us to look away from the particles themselves and toward the stage on which they perform, the vacuum of spacetime. For decades, we pictured the vacuum as a placid, empty nothingness, the ultimate state of zero. But one of the most revolutionary insights of modern physics is that the vacuum is not empty, and it is most certainly not zero. It is a dynamic, seething entity, and its structure is the key to solving the riddle of the hierarchy. The answer begins with the concept of sublime elegance, symmetry. In physics, a system is symmetrical if its properties remain unchanged after a transformation. The laws of gravity are the same whether you're on Earth or in the Andromeda galaxy. That's spatial symmetry. But what happens if the most fundamental state of a system, its ground state, its vacuum, is not its most symmetrical state? This is the phenomenon of spontaneous symmetry breaking. Imagine a perfect, infinitely thin pencil balanced on its razor-sharp tip. The setup is perfectly symmetrical. There is no preferred direction for it to fall. But this state is unstable. The slightest quantum fluctuation will cause it to topple, and when it lands, it will be pointing in one very specific, randomly chosen direction. The symmetry is broken. The crucial point is that the laws of physics governing its falls remain perfectly symmetrical, but the outcome, the ground state of the pencil, is now asymmetrical. In the first moments after the Big Bang, the universe was like that pencil balanced on its tip. It was a searingly hot plasma, a state of perfect symmetry where the fundamental forces we see today, electromagnetism and the weak nuclear force, were unified as a single electroweak force. The particles within this soup were all massless, indistinguishable in this key aspect, zipping about at the speed of light. But as the universe expanded and cooled, it underwent a phase transition, just like water freezing into ice. It fell from that unstable, symmetrical state into a new, stable ground state. It chose a direction. This cosmic fall was mediated by an invisible, omnipresent energy field that, until that moment, had an average value of 0. After the transition, its new ground state was a non-zero value that permeated every cubic millimeter of spacetime. This is the Higgs field. This wasn't just a theoretical fantasy. On July 4, 2012, the ATLAS and CMS experiments at CERN's Large Hadron Collider announced the discovery of a new particle, a quantum excitation of this very field, the Higgs boson. Finding the Higgs boson was like finally seeing a ripple on the surface of a vast, invisible ocean we had only inferred was there. It was the confirmation that the vacuum of our universe is not empty. It is filled with the Higgs field, a kind of cosmic molasses. This field acts as the universe's ultimate gatekeeper, the source of the forbidden hierarchy. It is the Higgs gate. As particles move through spacetime, they interact with this omnipresent field. The nature of that interaction determines their mass. Some particles, like the photon, do not interact with the Higgs field at all. They are like ghosts passing through a crowded room, completely unaffected. They glide through the field unhindered and thus remain massless, forever traveling at light speed. Other particles, however, do interact. They are like guests trying to push their way through that same crowded room. They are constantly bumping into the Higgs field, which drags on them, impeding their motion. This resistance, this drag, is what we perceive as inertia, as mass. The strength of this interaction is not the same for all particles. It's governed by a set of fundamental constants called Yukawa couplings. A particle with a strong coupling to the Higgs field, like the top quark, experiences immense drag. It becomes incredibly massive. A particle with a very weak coupling, like the electron, experiences only a tiny bit of drag and so has a very small mass. The neutrinos barely interact at all, making them the lightest of all. The hierarchy of masses is therefore not a property of the particles themselves, but a direct reflection of their individual coupling strengths to this universal Higgs field. The implications are staggering. This mechanism is not some minor cosmic detail, it is the master architect of reality. Without spontaneous electroweak symmetry breaking, every fundamental particle would be massless. They would all fly at the speed of light. There would be no way for them to bind together. No atoms could form. No chemistry, no stars, no planets, no biology. The rich, complex, structured cosmos we inhabit would be impossible, replaced by a thin, featureless soup of radiation. The Higgs field, by gating which particles get mass and how much, provides the very potential for structure to exist. The forbidden hierarchy is not a flaw in the universe's design. It is the central feature that allows for a design to emerge at all. And so, the question evolves. We have found the mechanism, the Higgs gate. We have found the gatekeeper. But this only pushes the mystery one level deeper. We are now confronted with the Yukawa couplings, another set of seemingly arbitrary numbers that dictate the fate of the universe. Why do these couplings have the specific values they do? Are they the truly fundamental laws written into the fabric of spacetime? Or are they, too, just the manifestation of an even deeper yet undiscovered principle of cosmic order? A grand unified theory that finally explains not just how the hierarchy is built, but it was built this way. We have peeled back one layer of reality only to find the next one.